you tell when you went over there?
For today, we're going to look at some of the proof versions of these problems, well, the co-function versions of these problems. These two are a smaller portion of your homework, but they can be the toughest if you struggle with the last homework assignment using identities. So, we'll look at those today. Tomorrow we will finish out this section, which will be basically applying these to non-unit circle problems. That'll be the last thing we do. It's only 2 problems in the homework, but it's probably the 2 most important problems in the homework, so we'll look at that for the entire block. And we start the next section on Thursday. So, as you're going through, make sure you're getting your homework done. Again, as was asked, I don't mind the order you do them in on your homework. If you want to do them in separately, do them in together, I don't care. Just get them into me. I prefer if we're all done on the same page. Order isn't nearly as important to me as that they're all done. Okay, let's look at some of the identity problems. First, co-functions. On your cheat sheet. Here, cheat sheet with me. Come on. Thank you, London.
You're welcome. I mean, they're separate notes, right? But
Ready. Didn't really spot it. No. Oh my gosh, it didn't help. What? I thought this one did.
Yeah, I did. Well, I don't take the ACT next week.
I'm sorry, I can sign up for one. You don't mind?
Okay.
Is mine better?
No. So, there are. These ones are ones that are not on your cheat sheet. These are very special case ones. There are a couple of these that might be really useful for your homework. They are direct ways to modify your trig functions into another trig function. Again, for this kind of problems, these are ones that are not on your cheat sheet. They are nice to have, but not required. They're basically just another way to simplify a function down to something a little nicer. They're contained in your textbook on page 714. And there are 6 of them. But again, you don't need these. They're just available for you if you want to use them or put them in your notes. They're nice to have because for some homework problems, they make it much, much easier to do. Basically, you can avoid doing a proof. Cosine of theta is equal to, sine of theta is equal to cosine of theta. There's number 1. Number 2, cosine of theta is equal to sine of pi over 2 minus theta. So notice that our first 2 formulas, they deal with sine and cosine and sine. They allow us to modify the particular function into a new form directly without needing some different formula. You can actually check each one of these, and some of your homework problems is to check each one of these just by plugging into one of the formulas that's up here on the board. They simplify to this version. The right-hand side will simplify to the left-hand side every single time. Okay, there again, it's well 6. So you have a connection between sine and cosine, we have a connection between cosine and sine. There's a connection between tangent and cotangent, the same basic connection. All these are pretty similar. So tangent of theta is equal to cotangent of pi over 2 minus theta. And then cotangent of theta is equal to tangent of theta for pi over 2 minus theta. So notice the right-hand side stays pretty consistent the entire way through. These are again connections between the other trigonometric functions. So sine connects to cosine, cosine back to sine, tangent to cotangent, and cotangent to tangent. Each one just connects in a slightly different way. And again, you can test any one of these by plugging them into those formulas. I'll do a video on the board. They all work. There are 2 left. As you can imagine, there's 2 functions left. Secant and cosecant, they have the same relationship as sine and cosine. For you, last 2. So, cosecant of theta is equal to secant of pi over 2 minus theta. And secant theta is equal to cosecant of pi over 2 minus theta. Particularly in, what problems are those? Those are 14 through 17. Those ones in particular would be very beneficial to have this function. The rest, hit and miss when they use them at all. That's why they're not included in the cheat sheet. They're not as common. I pretty much use them for this section and then never really think about them again. They're nice to know. They're just reaffirming that every trig function is related to every other trig function. It's just an extra one. And again, you can prove it very easily. Just plug any of them into these formulas. Okay? Take that first one and plug it into alpha minus beta and see what happens. Take that second one and plug it into the alpha minus beta and see what happens. It should simplify to that other version. The tangent ones, of course, are a little bit harder. Same with the secants. You have to modify them first using reciprocal, but it can be done. It's just a little bit of a pain. So, these are called co-function identities. They're a way to write the functions in a new function by modifying them by pi over 2. So last little bit of mini notes. And now let's look at the meat of the homework tonight. Proving. So last section, 9.1, we discussed proving a trigonometric identity. So we had to use the 4 big ones we had from last time, which were the reciprocal identities, the Pythagorean identities, the quotient identities, and the odd-even identities. All of those are still in play this week. But now we're adding one more section, the sum difference or addition subtraction rules. You may use any or all of them. Now, much like the odd-even rules, it's usually pretty obvious when you're supposed to use these ones, especially when you're given both ends, as we talked about last week. Because you'll have things that are supposed to be, theta plus pi over 3 or something else like that. It's obvious you're supposed to use this other technique. What's less obvious are the other 4 from last week. So, what's the problem? I'm going to work you through out of examples from the text, because again, there's not a lot of homework problems from this portion. But I will work through a couple of homework problems which I have also assigned. So feel free to take notes and copy them straight to your homework. Your first problem is where you're going to prove that one.
Or to proving.
Yeah, that's what we did last week, 9.1. Okay, it says prove that sine of alpha plus beta plus sine of alpha minus beta is equal to sine alpha cosine beta. So we're checking.
They write that.
Oh my God, what's so good? There we go. We're going to prove this identity. Now, this is not one that I've ever put on my cheat sheet. Like, it's not very useful. It's got a lot of components that have to be done perfectly. But every piece on here is related to one of the identities we talked about. Either one from last week or the ones we have on the board, the sum difference or addition subtraction. So, just like with last week, as a reminder, our 4 big steps. 1. Work on one side of the equation. Typically, choose the most complex. And now I'll modify that by saying the most obvious one as a first step. So if there's a complex first step that you think I can do that first step right now, that's one of the sides you should choose. Number 2, look for algebraic things to do. Factoring, distributing, squaring, combining, fractions, all of those are good. 3, pay attention to what your solution looks like, the other side, and make sure you're working towards that. If you have the opportunity to turn it into tangent for this problem, well, cool. There's no tangent in my solution. That's not really probably a great way to go. And then finally, if all else fails, converting things into base sine and cosine is always a good first step. So, let's take a look. We're doing a trigonometric identity. Trying to solve this thing and make sure it is right. Step 1. Work with one side of the equation. We have to pick a side to work with, so let's pick a side. On the board, we have 2 sides. The sine of alpha plus beta plus the sine of alpha minus beta. That is one side. And we have 2 sine alpha cosine beta. Which side should we start with? Left side. Why is left side such a good option?
I don't know. What is that?
Because it's pretty much the same thing.
Yeah, it's got a lot of components that are pretty similar. And we have new formulas that we talked about that make an obvious first step, right? I have sine of alpha plus beta. Well, I know what that is. It's right here. I have sine of alpha minus beta. I know what that is. It's right there. So that much should help. Okay? So I'm going to start with the left-hand side. As just by Levi. Good job. So I start with sine of alpha plus beta plus sine of alpha minus beta. Alright, now I need to make modifications to this, determine what this should be equal to. I already know what the solution is. My goal is to do the steps necessary to get us there. So, my next step, let's replace each of these pieces with the formulas we talked about yesterday. I know what alpha plus beta is. It is up here. Sine of alpha plus beta is a known function. It is on my cheat sheet. I should know it. So I'm going to replace that entire piece, sine of alpha plus beta, with the new version that we have in our formula. So this is equal to, okay, this first piece is going to become sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. So the first piece went from one thing with addition inside of it to two things with addition outside. What I want to point out here, and I know this is a good step because if I look at my solution contains multiplication, not addition inside. So it's probably a good idea to get rid of that addition inside. And then same thing with the second piece. The sine of alpha minus beta is going to become, so the same operation stays between, the plus stays a plus. So, I rewrite sine of alpha minus beta in the same way I just rewrote alpha plus beta. I go to my list. Sine of alpha minus beta is equal to sine alpha cosine beta. So, sine alpha cosine beta minus cosine alpha, cosine alpha, yeah, sine beta.
Wait. Whole top problem to prove is like one whole.
Yes.
Alright.
Sorry, let me make a distinguishing line here. That is my problem, on top.
Alright, well I wrote it like how you have it. So
Sorry. I ran out of room. I'll make sure to make that very clear. So, I'm trying to prove that sine of alpha plus beta plus sine of alpha minus beta is equal to 2 sine alpha cosine beta. I have taken the left-hand side. I have modified it using my sum difference identity into this new version of the function in the hope that something should simplify. Let's see what we got. Anybody notice anything?
You cancel stuff out here too.
Yeah, we can. What can we cancel out?
Sine of alpha cosine of beta, sine of alpha cosine of beta. There's two of those.
But they're both positive in those, right?
Yeah.
So we can't cancel these two because they're both positive, but we could combine them. Remember, I can always combine two things together as long as they're the same basic structure, like x plus x is 2x.
So here's your answer there.
Cancel the other.
So this gives us 2 sine alpha cosine beta. And yeah, that's my answer. So what happens to the other two?
They cancel out.
Why do they cancel out?
Because
Positive.
One's negative, one's positive, so they cancel. Leaving me with just this piece, which you'll notice is the right-hand side. That's how I know I'm done. So I use a trigonometric identity, the sum difference or addition subtraction to rewrite this function, and then use mainly algebra to finish writing it into my solution. Again, this feels a lot like last week because it is. We're just adding one section of things we can do. We're going to be able to do reciprocal, quotients, even odd, and Pythagorean. We've now added in some differentials. So those are also now options. And Levi, your first step, the right first step. I can see a sum difference rule, I choose that as my side. Just like last week, if I could see even odd rule, I chose that side first. Same goes here. If I can see one of those, that's probably the side I want to start with, so I can start modifying as quickly as possible. Again, the more modifications you make, the more that farther down the road, something's going to get fixed. So in this case, two pieces got combined algebraically, two pieces got canceled algebraically, leading to my solution, the right-hand side. Question? Do another example, and then I'll do a more problem. Let's see how I feel about it.
more homework.
Heck yeah. And then assigning like 30 problems at the end of the week and just doing like small sections of
Yay!
Okay. You get cracked. No? Ready? Let's see. Yeah. Alright. And Any objections to me moving past this problem?
No worries.
Proof. All right, what are we going to do here? Prove sine of alpha minus beta divided by cosine of alpha cosine negative beta is equal to tangent alpha minus tangent beta. Proof. Take a second. Don't start yet. Take in, absorb, let the trigonometry flow through you. Step one. I need to pick a side.
Left side.
Left side. Why is left side a good choice in this problem? It's a fraction. That's true. Like I want to simplify fraction once again.
Stuff cancels out.
Stuff should possibly cancel out.
And there's a negative.
There's a negative beta.
There's a negative beta. That's an even odd rule. That's probably a good place to start. What else? And there's a lot of good reasons to start with the left-hand side.
There's more stuff.
That's true.
And it's already sine and cosine.
Already sine and
There's
cosine?
already one of your addition subtraction things.
And there's one of my addition subtraction things. There's some difference things. Yes. All of those are great reasons to start with the left-hand side. So let's start there. Left-hand side. So as pointed out, and I'll get rid of all these markings here in a second, good reasons to start here. This one. I have a rule for that. That's probably the first place I might jump. This one. I have a rule for that. Again, a good first place to start. Like, it's giving me clear and obvious signs. Hey, dummy, start here. Start here. Please start here. Please start here. It's trying to give me the go-ahead signal. Go home. Go home. Round base. Nice, very nice. So, other things that can pop out. Yes, I have a fractions problem, right? We have all kinds of stuff in algebra to do with fractional stuff. That's not what I'm excited for. Like, I'm not excited to go, let's do a fraction problem, yay. But at least I know it's a possibility. It gives me steps I can approach to. All right, let's do this. Left-hand side is sine of alpha minus beta over cosine alpha cosine negative beta. All right, what should I do first?
I think we should get rid of the negative first.
Negative first? Love it. You said it, Levi. So tell me how do I get rid of that negative?
You should probably just like not right at the top and we're gonna change it the second round.
Where's the...
You look at the odd even thing.
I know, I was trying to find it. Shut up. It's just cosine. Regular cosine.
So the negative is going to disappear, leaving us with
Cosine beta.
this version. Again, that comes from, so in green up here, this comes from an even odd rule. I'm going to start trying to do that to give some good explanation for your notes, because otherwise it looks like magic in the next hour or two after you've had a break and haven't seen it, and while you go back to the problem, you're like, what did I do here? I don't remember.
That's not nosebleed.
Okay. What should I do next? I have successfully got rid of the negative denominator. Thank you, Levi. What next?
Probably do the top.
I would do the top. Yep. That alpha minus beta, let's fix that. So we go to my, in this case,
Sine.
we're going to use an addition subtraction rule.
Cosine.
All right. So the bottom, we're not modifying. We already did that. Cosine of alpha, cosine beta. Okay, what happens to the top?
Sine alpha
Second sine.
beta minus cosine alpha.
Sine alpha, cosine beta. And what happens next? Minus
Cosine alpha sine beta.
cosine alpha, sine beta.
Okay.
Not the way it is written right now, we can't. Because remember, we can only cancel if something's in everything. Now the bottom, because of multiplication, is good. The top, though, with that minus sign in there, poses an issue. So, what can we do next?
separate the top into two.
Beautiful, Olivia. Very nice. So we're going to separate the top into two. Now, when I do so, the bottom is going to stay constant. Remember, when you separate the two fractions, the bottom stays constant. So the first fraction will have the sine alpha, cosine beta, all over the bottom, which is cosine alpha, cosine beta. Minus. If you don't like alpha, just use A and B. Okay? These are just variables. All right?
Come on, Spud. Come on, Spud.
On the right-hand side, you saw that goal.
Huh?
Cosine of alpha, sine of beta, all over cosine alpha, cosine beta.
Did you say finish that?
Here we go. Now we can. So notice that my long-term goal was I want to see if I can get something to cancel. So Alexia got us to a place where we can cancel by splitting the fractions apart. We have in algebra ways to put fractions together and ways to take fractions apart. Like, you can use either one, use whichever one is best for you. I know this is a good thing to do because if I look at my solution, the solution has two things being subtracted. There's no fraction on top and bottom. So this tells me that's a great step to take. Okay, let's fix this thing now. So this is looking close. She says, Madeline, I believe said it was, we could simplify something now. Walk me through it, Madeline. Have the same thing on top and bottom, they cancel. Cosine alpha, cosine alpha. And what's left behind?
Sine over cosine and sine over cosine.
So for this problem in particular, it's very important to have the variables right. It's sine alpha over cosine alpha minus sine beta cosine beta. The reason why it's important is because you're already jumping into tangent, right? Because we see sine over cosine is tangent. It's a quotient rule. But that only works if the top and the bottom are the same variable. Cosine of alpha on the bottom and sine of alpha on top. They both have alpha in them, so we can simplify it. If they had different variables, we could not take this step. Here we go. Last step. So we went ahead and canceled. And now we're going to rewrite. So, using the quotient rule, sine of alpha over cosine of alpha becomes tangent of alpha. Again, they have the same variable. Think about it this way. If they didn't have the same variable, you have to ask yourself, what goes inside? And then you're still left with, oh God, what goes inside? And then you should be like, nope, this wasn't the right thing to do. Minus sine beta over cosine beta is tangent of beta, which you should notice as the right hand side. Boom. Look at that. Magical. Mystical. So, some of your homework problems also deal with alphas and betas. These ones specifically are ones we're assigning tonight. Ones like 47 through 51. That's those ones. But if you look at 33 through 41, they don't have alphas and betas. They have x's. That's the last piece we have for today. There's also identities that don't have different variables. In that case, when they simplify, sometimes they simplify very nicely because you can add and subtract variables like you did in Algebra 1, because you can do it inside. So this is where I'm going to do a homework problem. So like I said, what we just talked about helps us with 47 through 51.
Is that another section of our homework?
That is another section of our homework.
What the fudge?
Now, let's do your first one, number 33. Now, I want to point out about number 33, as I'll pull up here on the board in a second, is it says simply, use a graph to determine whether the functions are the same or different. So first, graph the two functions and see if they match.
Okay, so what's
Don't just jump into trying to do an identity problem. It says check it first.
So I need the homework.
Homework?
Yeah. What are they?
33 through 41.
Through 41.
And 7 through 51.
Oh. 47 through 51?
Oh. Yep.
God.
I know. Like 12 problems. My card I Okay. Let's do number 33 together. Again, number 33 says, read your instructions. The number of times they get asked questions where I have to sit there and go, can you read the directions? Because you're probably doing it wrong. It's too dang high. Okay? Let's read our instructions. It says, for the following exercises, use a graph to determine whether the functions are the same or different. So on 33, Garrett, you're right there. You wouldn't mind.
Read it, Garrett.
I think you're gonna sit down. Sorry, give me a second.
Missed it.
What? 33. What's it?
So I need to read the top part.
Nope, just fx.
Fx equals sine 4x minus sine 3x times cosine of x, comma, g of x.
Hold on. Times cosine of what? Sine of 4x.
Sine of 4x minus sine of 3x times cosine of x,
Stop. That's right.
comma,
Okay. G of x.
equals sine of x times cosine of 3x.
No way that's right.
Okay. So it says in the instructions, check this first. Are these two the same? If they are, we are golden. We don't do anything else. If they are not, we need to see if there is something we could fix this with. Maybe and it says specifically to make the second one correct. In other words, rewrite the first one using whatever trig identities we want to, so that we eventually get to something that is probably similar to this one. It might be, instead of 3x, it might be 4x. Or it might be 2x. We won't know until we try it out. Let's see what happens on 33. So again, I'm going to follow the instructions and graph these first. Okay, Garrett, I'm going to need that help one more time because I'm about to go to Desmos. Ready? We encourage you guys to do the same. Go to Desmos. We're going to type these in and see if they are in fact the same. Go to Desmos.
Hey man, I was trying to write that.
Hey man, it's in your book.
Hey man.
Alright, what's that first one again?
Fx
Is
sine of 4x
sine of 4x
minus sine
3x
times cosine of x.
times cosine of x. I love these ones because they just look so cool. I mean, look at that. That's like a heart attack.
G
Right there.
of x
Okay, g of x.
equals sine of x times cosine of 3x.
Sine of x. Cosine of 3x. Hey, look at that. They're the same. So on 33, I'm done. I write they're the same and move on to 34. Read your instructions. I can't stress this enough. So let's do problem 34.
Wait, 33.
Read your instructions.
They are equal stuff?
They're equal.
Wait, so we're not doing that right now?
No, it says if they're the same, you're good. Read your instructions. I cannot stress this enough. Okay, I believe 34 fails though. So, let's go to 34 now.
You should do that.
Yes, please. Alright, so,
Fx equals cosine of 4x
cosine of 4x. So
Plus
this is again number
sine.
33. Number 34, sorry.
plus
sine?
sine of x
Sine of x
times sine of
times
3x.
sine of 3x.
That's it.
Okay, so that's the f functions. This is again 34.
G of
Hey, look
x
at that. That's pretty cool looking. G of x
equals
negative
negative cosine
cosine
of x
of x
times
cosine
cosine
of
of 3x. Oh, they don't work.
But they're inverse.
Yes,
So.
So you just
Hmm.
take the negative away, right?
So the problem says to figure out a new way to write G to make them match.
Change
I have one proposal.
your inverse. Move the negative somewhere where it works.
So let's change this negative and see what happens.
Just delete it to that.
See what happens.
Okay.
We're done.
Woo!
Now you're done with 34. Read your instructions. It says finding modified versions. So on 34, your answer is the second equation, which is a changed version of chi. Please, please, please. Okay, read your instructions. No.
Sure.
I'm sure.
Really sure. Are we going to type it in? I'll read it to you.
No, use it now.
Just delete the first two.
I will take your word.
We're just doing homework together.
Huh?
I'm thinking about sine of 3x times cosine of 6x.
Okay.
I got this one on my phone.
So I'll put the homework on the board one more time. We got a few minutes left, so I'm going to open the floor if there were any questions from last time. I didn't give any time for that. So let's go ahead and do that. The homework assignment, again, number 33 is on the board. The answer is same. And I'm done.
33.
On 34,
Same.
the new g of x is the same function, which was cosine of x, cosine of 3x, with no negative. It just says find a new version. This answer only makes sense if you add 34 in the problem. Otherwise, it doesn't mean anything. Because g of x originally had a negative in it, now it does not. Okay, I'll open the floor now. Last night's homework was 25 through 32 and 10 through 19. Were there any questions on last time's homework? 14? I would love to do 14. Okay, a few moments. Reset here.
That's really good water. There's no water.
Not tap water.
Huh?
Not tap water.
Bottled water? Filtered water? From where?
No.
Your house? You have a filter? Or a fridge? I don't trust fridge filters.
I have a massive fridge.
Yeah, that's
14.
Good.
Oh, yeah?
Yeah, you want to brew that?
Oh, yeah. And you know what? Salt water never tastes so good. 14. So, if you have the co-function formulas memorized, this problem takes exactly half a second. The answer is secant of t. If you don't, we have to work through it and figure it out, which I will do now. So, my problem says cosecant of pi over 2 minus t.
Isn't this the formula we just found?
Yes. If you memorize, you know the answer already. If you don't, here's how you find the answer using the formulas from yesterday. So I'm going to use these formulas, which you'll notice only work in terms of sine, cosine, and tangent. Guess what? There's a way to switch cosecant into something else. I'm going to start this problem by using a reciprocal identity. Here we go. I start cosecant of pi over 2 minus t equals. Cosecant, as a reminder, is 1 over sine. And when we move and modify it to 1 over sine, everything inside will not change. So that is true. I have a 1 on top and a sine on bottom. That is one of reciprocal identities. Okay. Well, now, unfortunately, I have a nasty fraction with 1 on top and then this thing on the bottom. I'm not going to change that. What I'm going to do is I'm now going to use the sum difference rules. I'm going to change the bottom into something else. Here we go. So the top is going to stay the same. It's a 1. The bottom, I'm going to rewrite sine of pi over 2 minus t as this version of sine. So we do sine of alpha, so sine of pi over 2, times cosine of beta, so cosine of t, minus cosine of pi over 2 times sine of t. So I use the reciprocal rule to get to that version of the problem. Now I use the sum difference rule to get to this version of the problem. Notice the 1 has not changed. The bottom is the only thing I've modified so far. Now I'm going to go to the unit circle. Sine of power 2 and cosine of power 2 are both on my unit circle. I'm going to use those two values. Here we go. Equals. Again, the top is still a 1. I have not touched it at all. Sine of power 2. I go to my unit circle. Woo!
0.
No.
1.
1. Times
Cosine t.
cosine t. Minus
0.
0 times
0.
sine of t.
So this is 0.
Which means yes. That is
So
just.
it'll be 1 over cosine t.
Which is secant. So let me finish. So first thing I did, now I went to my unit circle. And now I get 1 over, so again, call it exactly right. 1 times cosine of t, that is cosine of t. 0 times sine of t is just 0, and subtracting 0 just goes away. So we end up with 1 over cosine of t. And now my last thing is, I use reciprocal identity one more time to get secant. Which you'll notice is the right-hand side. Again, if I have the formula memorized, then I already had that. I already know what secant t. If I don't, well, I can still get there. Just kind of take some work. Now let me tell you, the cotangent one is a demon. Because you got to do it this way. That's how you got to do it. And so simplifying it becomes a big problem. It's the hardest problem in your homework. And I believe that one is number 16.
They give you number 16.
No.
Hey, I didn't get question number 16.
I'm sorry.
I got 10 through 19, all of them by 16.
I'm sorry, I'm kind of stuck on it.
Can
You know, you could just use the code function and be done.
Could you help me? Well, I need you.
Oh, sorry, you were not here for those.
I need you to show me how to do that.
That was the very first thing we talked about while you were still gone. Okay.
Could you show me how to do that?
Did I save it? Did I save it? Did I save it? I did. Okay. There are 6 cofunction rules. Okay. They're not on your cheat sheet, is the thing. I'm sorry. Well, they're not common. They're only really used like once or twice. Like I said, like they're just not that common. So they're also in your textbook. They're on page 714 in your textbook. Again, you can go into this section and find them. I included it in your homework as well. I've been trying to do that, so if I ever reference something in the book and you don't have a book, it's still there, even if you're using an online textbook. Oh, and somebody did say something yesterday. All these are going from the same homework point, 9.2. And so I didn't upload the new homework because it's the same homework, it's the same paper, so let's go back to the other one. All these will be due on Friday.
Can you just like write down, say, instead of like doing individual numbers, can you just tell us what the whole assignment is so I don't have to,
Sure.
if I'm getting behind on homework, I don't have to go through each
I was planning on putting tonight the actual homework assignment, which would be all of them but one. So, yes. So it actually has a due date in the book. Let's see.
I'm like trying to figure out what numbers I'm supposed to do, and I'm like, it's not hard, it's just more work than I feel like I need to.
It should be 4 through 51. All. Yep.
4 through 51 all.
Yep.
Yeah.
Because the only part we have left that we have not talked about is number
4
20,
through what?
21, 22, 23, 24.
Hell.
If you're doing it in these small increments, it's not that bad, but like doing it all.
You fall behind, it's like, oh. Uh-oh. Okay. Please no. Yep, that's what I would do. Yeah, if you really believe. Otherwise, I gotta do it by hand, which I can do. I got skills. What can I say? But I wouldn't recommend it for everybody. It's a lot of pain and death and torture.
Sleep. Didn't do anything.
Oh, that's awful. I got worse.
Exactly. I don't remember what I did.
Tastes like soda.
I did not get carded.
Bad soda.
I was
Douglas.
Yes, sir. Yes, sir. What is the question? I will shuffle.
You just come right through.
Sure.
What do we do from here?
Simplify what you can, so I move the constants to the front of each of these. And I would answer, yeah. So this would be square root of 2 side x minus 1/2. Any other homework you want to see? We're only missing 20 through 24. That's what we're talking about tomorrow. And then we are finished with the assignment. So, any other ones?
If we're talking about that tomorrow, is it to
It'll still be due on Friday.
Friday? Are we going to?
The entire homework time will be due on Friday. I will move on Thursday.
You're moving on, you're not going
We will have extra time in class tomorrow to ask questions. So, gonna do what I can to try to get to those 5 in class.
Well, no, I was just asking if you were going to give us like a day's work.
Nah, I don't think.
What? Come on, I need the day's work.
Carter wants us to be finished early. To match Carter's schedule.
Yeah, but like,
I'm pushing the pace a little bit. I'm sorry. I didn't think about that. It's my first time doing it through Carter. We did it AP. And so if they want us to be done like the second week of May, I'm supposed to be done on the 26th. So basically we lost 4 weeks. But that means that the last couple weeks will be back to work. And we'll find out.
Do we just have the
Okay,
final?
thank you.
Do we just have the final in here, or do we have to take some sort of like?
Go fine.
We don't have to take this one, do we?
No, we do.
Full credit, yes.
So we'll probably be great. Cause like overall our stuff we learned.
But we're gonna be reviewing for that for a little while, aren't we? Okay. And you come up with
this is
something. You're not gonna kill us. I mean, you're gonna kill us.
Why would I kill us?
Well, you're gonna kill us, but you're not.
I am included in us.